Hey Jan, when I was looking at this problem, I think you made a mistake in a couple of places, perhaps, why you didn't get the same numbers as they did. On your confidence interval, um, when you do stat and then over to tests and then the one prop Z interval, you're to figure out what number responded. It's 55.2% of 774. So I did on my calculator. I'm going to do 0.552 times 774, and I'm going to go ahead and think of that as 427. I'm just going to round down. So if I do 427, because x has to be an integer, out of 774, my confidence level is 99%, and then I go calculate, I get 50.563 to 59.8, which is what they got. Now, let me see if on yours, if maybe you just use a different, let's see if you rounded up. Let's see if that's what happened. So if we change this to 428, and then we go down to calculate, that could be, maybe that's where you got the 60. Yeah, and the 50.7. So, I mean, I'll give you the credit for this for that part of the problem. I think what happened is you probably need to round down because you can't have a portion of a person. But somewhere in the lecture, I may have said to round up, so that it was a little finicky there. Normally, it gives you a little more room than that on the margin, you know, of what they'll allow. But I'll definitely give you credit for that part. Now, you had a question about this hypothesis test. Now, remember your hypothesis, you always compare, the null hypothesis always compared to the true or assumed value, which is actually what happened in the 1960s. So the null value is the 0.67%, and what you're doing then is in 2004, you're trying to see if there's a difference from the null based on your data. So you're wondering, is this 55.2, is that different? Obviously it's different, but is it different? Is it enough different to indicate that there has been change in the number of adults that have never been smokers? So you always use in your null hypothesis the assumed or true value, and then the alternative is that it's not equal, or it's greater than, or it's less than. Okay. Since they said, does this provide evidence of a change in the behavior, what you would do is you would look at your confidence interval and you would see whether the number that you got is in your, or actually you would look for the null value and see if it's within the confidence interval, and you can see that it's not. The null is not in there, so there is strong evidence of a change in the behavior. The other way you could do that is with a hypothesis test. So if you went over and did stat and then over to test and then did a one prop Z test, so your null is the 0.67, and I'm going to change 428. It's going to be okay, and then we do a not equal and then calculate. All right, so you see that your p-value is extremely small. This means that there are 11 zeros in front of the 4 because you move the decimal to the left 12 places. So your p-value is essentially 0. So the p-value is the probability that the null hypothesis is true based on your data. And so it's very unlikely that it's true. And so if the null hypothesis is true, if it's very unlikely that the null hypothesis is true, you reject the null hypothesis in favor of the alternative, which is what you did correctly there. There's strong evidence of a change in behavior. So you can do it with the p-value, or you can say, hey, the null value is not in my confidence interval, so it must be that there is a change in behavior.